Yeah, thank you very much for inviting me. And actually, I would like to start from the observation made by the colleague here. I'm talking about artificial intelligence. I'm also a scientist. I'm a computer and data scientist by background. But the main topic of my work, and the work of increasingly many people, is how to develop human-centered forms of AI, tools that are actually technologies that become useful for facing the challenges that we have as individuals and that we have as society. And this is the framework in which an increasing number of interdisciplinary scientists in Europe and worldwide is actually concentrating. And I would like to, this actually boils down to many truly scientific questions. It's not just, let's say, an haphazard goal, but it boils down to develop forms of artificial intelligence that are truly very different from what we have today and that need new foundations, new interdisciplinary work. For instance, for how to have machine learning with the human in the loop, for instance, because we want co-evolve with machines that can help complement the most cognitively weak part of our reasoning, for instance. And there is a long list. I would like to concentrate on one specific that, in my opinion, is an emerging new scientific discipline at the crossroads of many current disciplines, including AI and complex systems especially, which is the social dimension of artificial intelligence. It's something that we are experiencing very much in our everyday life. We see the emergence of increasingly complex large socio-technical system where people interact with the mediation and the modulation also of AI assistants. And this is truly a new social and technical dimension that we need to understand better if we want to strive towards the right direction and avoid the pitfalls and seize the opportunities. Examples, mobility. We drive with the assistance of navigation apps, right? That they are truly important, especially when we travel in unexplored cities, for instance. Or we have social media or media, information media in general, that are very much mediated by recommender system that also help us navigate into an ocean of possibilities. But at the same time, of course, they may entail issues. Similar example, online marketplaces, e-commerce in general. We are many everyday big or small choices are really mediated by tools that increasingly help us or nudge us or manipulate us in our decisions. And there is one interesting aspect here. If you look at the history of artificial intelligence, most of the work, I would say 99.9% of the research work since Turing and afterwards, is very much rooted in, let's say epistemological individualism. You try to build systems that make individuals more intelligent into some broad system. This is what happens with navigation apps, for instance, right? Navigation apps learn from, of course, from the geography of places, the road maps and street maps and so, but also from the behavior of people that in the past made certain travel choice, right? The recommender system online learn from previous user behavior and, for instance, recommend to an individual person what to buy or what to read or what to listen to or which movie to watch based on previous choices of people that's similar to you. And that's an important issue that is very, I would say, natural in this community. A crowd of many interacting, individually intelligent agents or people does not really make an intelligent crowd overall, right? And on the contrary, we can see very stupid aggregated behavior in certain cases due to the things that we know very well, that in complex system, entities interact and interfere each other. My choice can impact many other choices and the other way around. And this, most of the times, happens on top of common resources that we all share, like the public discourse, or the street map of my city, or the economic space. And therefore, we see that in many of these situations, this intelligent, let's say, this selfish individualistic intelligence boils down to an aggregated outcome that it can be far from interesting. It could exacerbate, for instance, opinion polarization over social media. It can bring to even stronger inequality effect in economic networks, or can bring down to congestions, pollution in traffic and mobility. I would like to concentrate today on a couple of examples and then conclude with, let's say, a call for action that we should all embrace in this area. First of all, social media. Let's look at or media in general. We try to. There is a lot of people. We began in a couple of years ago, 3 years ago, to try to study systematically. This is probably the first theoretical study to understand the effect of algorithmic bias, recommender system in social media. Opinion dynamics is essentially there are plenty of models since the 90s or even earlier that try to understand this form of epidemics, right? How the epidemic spreading of opinions in a population or a network or a social network, trying to somehow model how we interact and influence each other in forming opinions. Typically, the idea is that when two persons have an interchange of some, interact, in general, there will be some updating of their opinion somehow, which will eventually propagate in the network. And of course, by simplifying in a model, you can either resort to continuous model where, let's say, the opinion can vary over the continuum, I don't know, 0, 1. I'm absolutely in favor of vaccines. I'm absolutely contrary to vaccines and all the intermediate position, or in a simpler, totally discrete 0, 1 situation. I would like to show you now very quickly the effect of algorithmic bias in a very simple, one of the simplest opinion diffusion model, which is the DEF1, or bounded confidence model, introduced in 2000s, about 20 years ago. Here we have essentially a continuum space. Every individual, it's a population model, like SIS, SIR. It's there is no network. It's a mean field, essentially, approach, where every person in the population carries an opinion between 0 and 1. Okay, and the idea is that at discrete timestamps, at every iteration, two persons are totally randomly selected for interaction. There is a parameter to the model, epsilon, which is this bounded confidence, or let's say the open-mindedness, average open-mindedness of the population, that essentially plays a role when two persons are selected. If the two selected persons for potential interchange have a difference in opinion, which is at most epsilon, they will actually interact. Otherwise, they will not. Okay, so the epsilon is perceived as the maximum difference between the opinion under which two persons accept to exchange their opinions. The idea is that if the distance is less than epsilon, the two persons will interact and their opinion will become closer. Okay, it's very simplistic. The point is not somehow ending with this is really by design. We wanted to start with something very, very simple, simply to see what is the effect of adding the algorithmic bias. But before that, I just want to show you with this picture the effect that this epsilon parameter has on the, let's say, on the evolution of the population. No? This is time, essentially, okay? And this is the initial distribution of opinions in the population. And these are 3 simulations in the model with very, very small confidence. Basically, almost everyone remains of the same opinion, or there are many, many segregated opinions. This is 15%. You see that two parties emerge, in a sense. And this is confidence 25. You see that eventually there is a consensus. It is an interesting model also mathematically. It is possible to show that always converge to a stable situation. And there are critical values of this epsilon parameter that determine the number of parties that you observe. Now, what happens how can we model the introduction of the recommender system? Recommender system on platforms, on real platforms, like on social networks or social media, don't somehow extract 2 random people or a random people and content. No, they will try actually to favor for instance, couple of peers. If Facebook is proposing a certain person to become your friends, it's because you're very like with the similarity between the two is very high. So the likelihood that the opinion is very close is very high. So the way we model this is essentially by replacing random with a preferential, let's say, probability, saying that the closer the opinion of 2 people are, the more probable is that these 2 people are selected for a potential interaction. Okay, this is the only change. Of course, there is a parameter gamma here, which gives the intensity of this algorithmic bias. Simply this. So the extraction is not random, but is biased by this preferential probability. And this is the result. Of course, I'm totally skipping all mathematics, simply showing but this is a normal, let's say, evaluation of a different simulation with gamma epsilon equal 32, which means there is a very ample bounded confidence, open-mindedness, and so as you see, the system very quickly converged to consensus. And this is the same system, the same open-mindedness with the bias. You see an amazing effect, right? Actually, double effect. Because the most, let's say, evident is that we have consensus there. We have instead polarization here, 2 distinct parties emerging. And this happens for a totally artificial thing. It's just the same crowd that could reach consensus that is somehow nudged not to reach consensus due to the recommendation mechanism, which I think is already kind of, let's say, strong phenomenon. The second is look at the numbers which is time on the x-axis in the 2. This is 2 orders of magnitude longer in time. So not only the process converges to a totally polarized situation, but also it takes an enormous amount of time. So essentially to remain in continuous instability for a long, long time before reaching a stable situation, which is polarized. So I hope these are just other examples of the same. The effect is always, as I said, much prolonged instability of the society, of the population, and larger numbers of opinions. You see, you have 1, you end up in 2. You have 2, you end up in 3 or more. Okay. In a sense. This is, of course, purely theoretical, overlay simplistic model, but it shows the problem. mediation mechanism, only who you select for something that is totally unrelated with the content or with the, it seems to respond to an obvious, let's say, interest of the platform. What is the interest of the platform? That people interact, that people read content, and therefore, if I am proposing to people something that I know they like, that they found somehow natural to look at because it's close to the personal preferences, something that in principle seems to look like innocent in a sense, it is actually not at all, because it can totally destroy, for instance, the ability of a population to reach a consensus. No, simply for the, let's say, the rule of the games, in a sense. And unfortunately, if you go ahead and instead of looking at the population, you look at the social network, we know very well that complex networks are not only hyper-connected small words. They have a natural tendency to cluster in communities. They have a natural tendency to develop long-tail distribution and inequality between super-connected nodes and poorly connected nodes. And we put also this situation behind this model, and you see that actually the fragmentation, the polarization is even stronger and happens in a stronger sense. So this is, for instance, work that has been performed by my colleague Janos Kertész in Central European University, showing that really very much the effect can be exacerbated when we consider the network structures as well. And it is also possible to see in these networks that if the platform, on top of this algorithmic bias, there is also nudging towards, there is a preference in the network towards an opinion, right? Then this can be even more dangerous, because due to this accumulation effect, even a small nudging can essentially manipulate the entire community and determining in a sort of, there are a couple of studies on this, that different models that comes to the same results. So I really hope that you perceive that it's an important topic. We need to understand better this phenomena. Of course, it's too simple. These models are too simple. They may miss important, let's say, confounding variables. There are very limited empirical studies. And this is why there is really a call for better empirical work that is tough to be done, because it's very tough to do this kind of work with publicly available data. And that's why I would like very quickly to glimpse you a project that I am pursuing as an Italian member of this GPAI. GPAI stands for Global Partnership on Artificial Intelligence, and it's an international organization made of 25, an initiative of 25 governments globally, including the European Union, US, UK, Australia, New Zealand, Canada, and more, that is trying to address essentially the responsible use of AI, and specifically a project that I'm co-leading is this sub-project on responsible AI for social media governance, to try to have a framework where we go beyond simple models, but we are able really to measure and audit these systems to understand to what extent they can be safely used, or whether they can be threatful for the public discourse in democratic countries. By the way, a topic that is becoming very, very hot in the global discussion, and specifically in Europe, because in Europe we are discussing a directive, a European level law that will be in 2 years adopted by all the member states of EU. It is called Digital Service Act. And this law requires that all large platforms for media, e-commerce, whatever, or mobility, that are large in the sense they have a number of users that is more than 10% of the European population. This is defined in the law, will have to be auditable. from the governments. They will somehow need to answer with evidence to questions like, for instance, the question we are trying to solve in this project. A question which is it true or false that the recommender system of a large platform is driving users towards harmful content? Toward content that is harmful in the sense of extremism, terrorism, violence, and hate speech. Does the platform, intentionally or not, and probably unintentionally, can run the risk of driving people into dangerous direction? And the reason why this question is scientifically legitimate is really connected with what we have discussed so far, right? In this system, we are, this complex system, we are observing something that is new, that is due to the adoption of AI in the system. It's not only a matter that the user in the system are influenced by the platform, but it's also true, thanks to the AI, it's true the other way around. It's true that the mechanism in the platform are influenced by the behavior of the users, okay? Because the AI recommender learns from the behavior of users, and then the users are influenced by the suggestion of the recommender system, which will later be retrained on this, and you can see a reinforcement feedback loop that can actually bring the whole system into new forms of instabilities, new forms of emerging properties with respect to those that we already know in systems that we can somehow observe from a simpler perspective. And that's the core of my call for action today. We really need probably new good science to understand and model this kind of phenomena. Taking into account that we know already from social psychology that we as readers, as news consumers, we do have a lot of bias that are routinely exploited by journalists and media, right? We have a bias toward strong moral emotions, towards negative sentiments. It's way more probable to see a murder notice rather than something happier and ordinary posted on newspapers. We tend to be curious about extremistic position by itself, right? We have a bias even towards false information, because we somehow, maybe we understand at a certain moment it's false, but we are attracted because of sensationalism. And if the recommender system is able to reflect this bias by learning from our experience and amplify this, then of course we might end up towards something very dangerous for our opinion, because remember, these are tools are hacking a public good, which is public opinion, public discourse, which is essential for democracies, right? So this is, let me go to the message here, because I also have another example that I would like to tell you. This can only, to really answer this question, answer the question, do the recommender system of platform X entail some danger, perils of this form, can only be answered from within the company, not looking from us. I need to know what is the effect. These are interventional or causal empirical. It's something closer to a randomized control trial. Taking the recommender system as a kind of therapy, I need to know what happens for users that take the recommender system and users that don't, to compare whether there are differences. And we have designed a study in New Zealand that we plan to run with Twitter. Let me only tell you that recent work by Twitter is showing that it is possible to do that. I tell you very quickly what they did in a very recent paper appeared on PNAS a few months ago. They studied essentially the different kind of behavior from two populations of users that they can access. Users that are actually using the recommender system provided by Twitter, and users that don't, that only follow the post of their followers in chronological reverse ordering. No? You see the difference. No? In one case, a person in his or her timeline receives objects, tweets that are selected by the recommender system based on preferences of the user. The other population is using a totally different system. They don't really have a recommender system. They only are exposed to social influence. They only, in their timeline, they see in reverse order, the newer are on top of the list, the contents, the tweets posted by the people that they are following, okay? And they ask the question, does political content, so content from political parties, from political leaders, is amplified in the same way or not? And they find, yes, political content is very much amplified with the recommender system compared with the no recommender system. And also, interestingly, they find, and they published, the fact that right-wing content, you see these are different countries, US, Japan, UK, France, Spain, Canada, and Germany. In all these countries, except let's say, the exception of Germany, right-wing content is more amplified than left-inclined content. You see, not only there is an amplification, but the amplification is biased in somehow, where the bias is not into the algorithm, right? The bias is learned from the activity of users. And just to tell you, there are really very, very little studies of this form. But another example is this study, totally empirical and not so large, from Lee and Oganasar a few years back, that they made an empirical investigation on the impact of recommender system on Amazon, retail system. No? And asked the question, but if using the Amazon recommender system, let's say you may all know, no? You go on Amazon, you say the people that buys this also buys that, right? Which is typical AI recommender system. What is the effect on sales, individually and globally? And they found a very interesting pattern. They found that individual diversity of purchase is amplified. People buy something that they wouldn't even buy otherwise, but the aggregate effect is that of reducing diversity, because there is a clear nudging towards the same set of very popular products. So it's an amazing fact, right? It's something that in principle would somehow be thought as a kind of innocent, again, way of promoting sales. It actually has an effect as a perturbation to the market fairness, in a sense, right? Because this comes at the expense of niche or small advertisers. Okay, I'm going very quickly to the end. I only want to say, Riccardo, that in opinion diffusion, it's I'm completely aware that it's difficult to measure. It's difficult to measure what people has in their head. In mobility, understanding what is the final effect of navigation apps that can inadvertently create troubles is something that can be measured. Can be measured by the people of a small country village that in certain conditions get flooded by, this has happened many times in many places. In a certain moment, to avoid congestions on a highway, you reroute people on a rural, let's say, alternative road, but you do the same suggestion that for 1 or 2 or 10 cars would be very clever. You do the same suggestion to 1,000 cars, you will end up creating an even bigger mess somewhere else. And it's interesting here that this is a new stream of work that we are pushing very much right now. We have a simulation framework to understand, from real data concerning both car mobility and also street maps, of course, how different, let's say, percentage of people following a normal TomTom, let's say, kind of apps, what are the dangerous situations? For instance, in this work, we were able to see that once you reach the 40% of people somehow that are following the recommendation of a navigation app, you have a kind of ideal, this is the total emission, the CO2 emission in the city, you have a kind of better situation at a certain moment. And we are actually exploring better how much the diversity of the itineraries of the people that can be somehow pushed by a different mechanism can even reduce this much more. But the point is that when you see that when the fragment of people following the advice increases, you get to very, very quickly to a situation where emissions become untractable, essentially. And you can even understand better things like, there is a study done on, essentially, it doesn't show very well, but this is London, this is Rome, and here is Florence that is not visible. A real study in this situation showed that, for instance, another complex system style property, if you look at who are the worst polluters, you discover immediately that the distribution of the pollution contribution by cars is again a power law. So you can actually select a small percentage of cars having a big impact in reducing. If you're able to deal, for instance, to send on electrical cars or some other form of mobility, this fragment of people, you can have a big impact in emission reduction. So this is the story. I believe that social AI is a really fascinating new avenue for research, but there is not sufficient study on this area, both theoretically and empirically. We really need a step ahead in transdisciplinary integration of artificial intelligence with complex systems and computational social science, and because I believe here there is a lot that we can do for driving our social systems within, of course, an ethical and legal framework that is not decided by technologists, it's decided by the democratic process, but in a sense, within outcomes that we set collectively or together, we can somehow devise technologies that, I don't believe technologies will solve the problem, but technology can be part of the solution instead of being part of the problem. This I think, it's a big responsibility that we as scientists have, and I believe we can do really much better. I'm skipping this, and I just want to tell you this. It's really time now Alan Turing has been a great guy, has inspired 70 years of artificial intelligence, but it's time for his test, this imitation game, to go in retirement. We don't simply need systems that are good at imitating us. We need much more. We need systems that are intelligent because they allow us to become more intelligent in tackling complexity. This is the real new mission that I think we should embrace for the future. Thank you.
Thank you, Dino, for the fascinating talk. I hope you have not manipulated us into
Sorry?
I hope you have not manipulated us in thinking. Questions? Yeah.
Thank you for your talk. I have two questions that are related. The modification of what you call the Dufan model. No, Dufan model. You said that you introduce a distribution according to distances. How you define How the distribute? So they are independent on the distribution of the distances. So the distances, how you choose the distances between. So you define an opinions, and then you have to select how many as how many people have.
As I said, in this model, it's on purpose extremely simple. As I said,
So-
opinion is just a number, right?
Yeah.
I have opinion
Yeah,
0.1 and you have opinion 0.5.
Okay, how they distribute
The
it?
difference is simply how
Yeah,
close
but how
we are.
are they distributed?
Of course, this is the initial distribution is a parameter you can set
Uh-huh,
up.
okay.
The simulation I showed are uniformly distribution at the beginning, but you can also play with different initial distributions, like a Gaussian with a certain variance. We didn't observe much of a difference by changing this.
Okay, thank you. The other question was about, was thought about a sort of change of the paradigm in defining, for example, I'm thinking about opinion dynamics. You know? You're saying that I appreciate the fact that rather than saying a sort of utility that an individual should maximize is usually assumed, you're talking about sort of bias, no? So it means that there is a sort of approach, a heuristic approach that people use, a sort of rule of thumbs that people use to select, for example, a destination or opinion. My terms is always the same. Plus, sort of, I would say, a frustration in the selection of the opinion, because you have to not spend a lot of time make a decision, and the conclusion of the decision should not be something that will frustrate me. So usually we have this bias in order to select the opinion that seems to be better rather than maximization of benefit cost, utility. They are very mathematical, but are away from the individual's dynamics.
No, this is a very good question, and it shows the difficulty of the problem. The reason why recommender systems that are based on similarity, like-mindedness, are very effective, of course, because they put a very little burden, cognitive burden on the user, right? If I see a suggestion that is somehow not totally useless, but close to my perception, close to my bias, of course, I immediately feel very little effort in considering it and maybe adopting. And that's the reason for their success, essentially. Of course, if you want to instead recommend for diversity, if you want to recommend, well, yes, you're talking about this topic. Have you considered this other's perspective? That's much more difficult to do because you're immediately talking to the rational part of the system 1, system 2, right? The old good Kahneman. You're talking to the rational part of the person. And you know that engaging people on the rational part is much more difficult than engaging them on the system 1, on the intuitive part. No? The recommender for similarity talked immediately to the system 1. And that's where I believe we need to invent new good stuff, new good ways of somehow engaging people, allowing them to think that something that is not totally obvious at the beginning is probably the better choice. I know it's difficult. It's similar to in navigation apps, say, are you willing to, in your 20 kilometer strip, to make 21 or 21.5, but contribute to a situation where you and all the others will be quicker in the end. Again, it's a kind of, not obvious. I simply want the quickest or the shortest. It's difficult for people to imagine that if other 500 people will do the same choice, it's like, the vacanze, partenze intelligenti per le vacanze, no? If we all do the same very intelligent departure, it will be a very stupid departure. So, that's the point where we need to be ingenious from the design point of view, and also we need probably better in communicating, also in a way that is comprehensible not only to scientists but to everybody, especially politicians, they're the toughest part, to understand that design of apparently simple mechanism is actually disastrous in certain situations.
One last question.
And so you showed that if you have an organized network, so the result of the bias is also okay. You say that if you have an organized cluster, the result of the bias can be also more effective for some. But what's if you add some other possibility that part of the people change from one cluster to another because of external causes. So for example, people become richer or changes his situation for some reason. So you add some other dynamics in the system.
No, it's a very good point. As I said, the simplicity of these models is that they assume that we are observing all the causes, you know, for change. And of course, this is not true. You know? There can be external causes that, for instance, make a person shift in opinion or in behavior. And of course, there are two ways to play the game. One is to make our models more and more realistic by taking into account more features as it becomes possible, also from an empirical point of view. The other possibility is instead try to make a real experiment in the wild to understand from the experiment what are the variables that we can factor out more effectively. But I really believe that this is part of the game we are trying to understand. And there are, of course, systems that are in a sense easier than others. So I showed opinion diffusion first because I know it's a terribly difficult situation because, as I said, we have lots of measurement problems there, right? We cannot really open the head of people and measure the opinion. For instance, traffic, for some extent, it's a bit easier because we can measure better, know how long is a trip and what is the total emissions or the total time spent by people in car and so on and so forth. So in different situations, we will probably come up with different answers to your question.
How the system is sensible to small external perturbations, no? If you add some small, little weak perturbation, the result is the same or completely changed. So external perturbation, I mean, for example, changing some aggregations and so on. So if everything changes or no, it remains stable.
No. If I understood your comment correctly, I may not. I totally agree that we should combine tools from all fields, including instrumental variables, for instance, from economics, just to make one example that can help us somehow to make the models let's say, the reasoning as robust as possible with respect to the confounding factors that, of course, we are talking about society, so there are many, many different confounding factors.
I need to cut this discussion. So we are running very late, so let's thank Dino again.